A quiet state in the US is hiding a massive geographical anomaly, and it's time to expose it. Let's take a closer look at the US Pacific Northwest. If you think that Oregon is all about a peaceful, rainy paradise covered in vast green forests and towns by the coast, the map is lying to you. Drive just a few hours east from those rainy woods and the green suddenly vanishes. Oregon is an incredibly rare place on Earth as multiple destructive geological forces hit the exact same spot on the map. The answer to that lies deep underwater. A massive tectonic collision is taking place right under it. The ocean floor is literally shoving itself underneath the North American continent and creates enormous power. It pushes up the ground right through the middle of Oregon, forming the Cascade Mountains. They're basically a chain of hilly, explosive volcanoes. This natural wall also acts like a massive shield, trapping all the heavy ocean storms on the western side.
Hey, hit subscribe.
Dominoes are working. Dense rainforests can easily grow in those conditions. Another step? The second you cross the peaks of the Cascades, all the moisture vanishes, leaving the eastern part of Oregon as a completely dry region with high altitude. It's not over yet. All this eastern region lies on top of an ancient sea of frozen magma. Millions of years ago, the ground here was ripped and flooded with molten rock, burying the entire state. And we're not talking here about a regular volcano erupting. It was one of the most violent and massive volcanic events in Earth's history, known as the Columbia River Basalt Group eruptions. Earth's crust was torn open, with fissures even miles long. Lava didn't just flow, it looked like a colossal boiling fountain with an unstoppable tsunami of fire. This apocalyptic act literally paved the eastern half of the state in solid stone, locking it in a dead, dry state forever. That's why it now looks more like Mars, not America. Knowing all of this, when you look at Oregon, think of it like one of the unique places on Earth with almost impossible contrast happening in the same place, same time.
Deep beneath South Dakota inside the Sanford Underground Research Facility, workers are digging caverns nearly 4,800 feet below the surface. They drill, blast, and carve their way through solid rock. More than 800,000 tons of ground have been removed. They're not opening a mine, and they're definitely not looking for gold. They're digging for answers to some of the biggest questions humanity has ever asked. How does our world actually work at the deepest level? Why does matter exist at all? How are stars born, and how do black holes come into existence? The answers aren't hidden in some underground vault or buried treasure. Instead, these caverns are part of one of the most ambitious physics experiments ever attempted. The Deep Underground Neutrino Experiment, better known as DUNE. Down here, far below the noise of the surface world, scientists are installing enormous detectors designed to study some of the strangest and most elusive particles in existence, neutrinos. What are these particles? Why do we need to go nearly a mile underground to study them? And what could they possibly tell us about the universe and about us? Let's find out. By the end of this story, you'll feel a little more like a scientist. So why are neutrinos such a big deal? Because they're everywhere. They're among the most abundant particles in the entire universe. And yet, at the same time, they're almost completely invisible. These tiny subatomic particles pass through matter as if it barely exists. Right now, this very second, around 100 trillion neutrinos are passing straight through your body. But you don't feel a thing. Neutrinos are incredibly light. For a long time, scientists weren't even sure they had mass at all. That's why they're often called ghost particles. They're everywhere, constantly streaming through space, planets, and people, but almost never leaving a trace. Neutrinos are created whenever atomic nuclei collide or decay. They're born in nuclear reactions, radioactive processes, and energetic cosmic events. They even come from something as ordinary as a banana. Bananas contain potassium, which is slightly radioactive. That means every banana quietly produces neutrinos. Don't worry, the amount is completely harmless. You can eat bananas without fear. But the biggest neutrino factory anywhere near us is the sun. deep in its core, nuclear fusion is happening non-stop, and neutrinos pour out in staggering numbers. The sun floods our solar system with them every second. And beyond the sun, even more powerful sources exist. Exploding stars, supernovas, and possibly even black holes. Neutrinos may also be connected to one of the greatest mysteries in modern physics, the disappearance of antimatter. According to our best theories, the Big Bang should have created equal amounts of matter and antimatter. Antimatter is made of particles with opposite electric charge. When matter and antimatter meet, they annihilate, turning into pure energy. And yet, here we are, living in a universe made almost entirely of matter. The antimatter is gone. But why? Scientists don't know. One leading idea is that neutrinos played a role tipping the balance. Somehow, early in the universe's history, neutrinos and antineutrinos may have behaved slightly differently. That tiny imbalance could explain why matter survived and why galaxies, stars, planets, and people exist at all. So neutrinos might hold answers to how the universe works, how it began, and why it didn't erase itself. But there's a problem. To study neutrinos, you have to catch them. You have to observe their interactions, measure their properties, and see how they change. And that's incredibly difficult. That's why scientists are digging giant caverns in South Dakota. Why underground? Why not study neutrinos out in the open, in a field, on a mountain, or on a sunny beach? Because neutrino detectors need silence. Not silence from sound, but silence from radiation. Neutrino detectors are massive, extremely sensitive machines. They're built to notice incredibly rare events, but Earth is constantly bombarded by cosmic rays and background radiation. At the surface, those signals would completely overwhelm the data. Going deep underground solves that problem. Thick layers of rock act like a natural shield, blocking unwanted radiation and creating a quiet environment where neutrinos have a chance to reveal themselves. That's why Dune's detectors sit underground. In total, Dune will use 4 gigantic detectors, each about the size of a 7-story building. Together, they form a single experiment, but the heart of the project is actually far away, at Fermilab near Chicago, about 800 miles from these caverns. From here, a team of scientists will release neutrinos that will travel through the underground, and giant detectors will collect information about them and transmit the data. But how do they catch the information? The detectors will be filled with liquid argon. It's a cryogenic, colorless, odorless, and tasteless substance extracted from the air by liquefaction. Liquid argon creates an inert environment that greatly helps scientists in their experiments. Imagine that our world is a huge canvas with millions of drawings and colors. So liquid argon is such a white piece, a perfect place for studying tiny particles. When neutrinos collide with this liquid, they create other particles. Detectors read those particles and send the information to the lab. Then scientists from all over the world begin to carefully study these data. They hope to create a clearer picture of the universe, to understand why matter rather than antimatter dominates here. But what do we care about this information? Why is knowledge about matter important to us? Because we're part of this matter too. By manipulating particles, scientists will be able to find out what happens to neutrinos during the explosion of a star and the birth of a black hole. So, scientists collect invisible neutrino particles which are associated with the birth of the universe, star explosions, and black holes. They release them into a single beam and launch them through detectors. Everything seems clear, but where did they get the neutrino beam from? And how do they get them? It starts with hydrogen gas. Scientists take hydrogen atoms and strip away their electrons, leaving behind pure protons. These protons are then fed into a massive particle accelerator, where electric fields push them harder and harder, faster and faster, until they're moving at nearly the speed of light. Then they're smashed into a solid target made of graphite or beryllium. The impact is so hard that the atomic nucleus breaks into a spray of new, unstable particles and explodes outward. Among those particles are pions. Pions are extremely short-lived, Almost instantly, they decay into other particles, neutrinos and antineutrinos. Powerful magnetic devices force the pions to fly in the same direction. Chaos becomes order. A wide spray of particles turns into a tight, focused beam. That beam then slams into thick blocks of aluminum, steel, and concrete. These blocks act like a filter. Muons and other leftover particles can't go through it, but neutrinos are different. They barely interact with matter at all and pass through the filter. What emerges on the other side is a clean beam of neutrinos. Right now, the caverns are complete. The first dune detector is expected to turn on before the end of 2028. Around 1,500 scientists from 36 countries are waiting for the experiment to begin. All of this might look familiar. Giant caverns, tiny particles. Scientists are chasing the deepest structure of reality. It sounds a lot like the Large Hadron Collider, but Dune and the LHC have different goals. At the Large Hadron Collider, scientists accelerate particles, mostly protons, to near light speed and smash them together. The goal is to recreate conditions similar to those just after the Big Bang. The LHC has already confirmed the existence of the Higgs boson particles that help us to understand why some elementary particles have mass. The collider may also help uncover dark matter, an invisible form of matter that makes up about 27% of the universe. Stars, planets, galaxies, and everything we can see are about 5%. The rest is dark energy, a mysterious force expanding the universe. Dark matter, dark energy, invisible ingredients shaping reality itself. None of it is easy to understand, but experiments like Dune and the LHC help us to make sense of it.
Do you know what one of the most dangerous and scary lakes in the U.S. looks like? Let's check it out. This large lake is filled with blue water reflecting the sun's rays. Lush thickets of oaks and other trees surround this picturesque place. More than 150 small islands, which are the tops of hills, stick out from under the surface. People come here to swim and play frisbee, go boating, and sit quietly on the sand. Nothing dangerous, right? But if you dive underwater with scuba gear and start exploring the seabed, you'll see that it hides old fishing nets, broken sunken boats, debris of houses, and even graves. If you go to the local library and start researching the history of this place, you'll find out that many people were kicked out of the area against their will. You'll learn that there were terrible conflicts between locals here. You'll understand that the idyllic picture hides a terrible drama and hundreds of tragic fates. This is Lake Sidney Lanier, which is in North Georgia. It was named after writer Sidney Lanier, who created the poem Song of the Chattahoochee, dedicated to the river that feeds the lake. Despite the beautiful view, this isn't a natural body of water. Sidney Lanier is an artificial lake created in 1956 to fight floods caused by the river, to provide people with drinking water and hydroelectric power. The perfect place for creepy stories that often happen in small American towns. Before people created the lake, about 700 families inhabited this place. They made up a classic quiet village with farms, houses, churches, mills, and a cemetery. But when the state decided to create a lake here, the authorities forced people to leave their homes. Locals had lived here with their families for generations, and then they had to go away. Most of the buildings were moved, but the cemetery was left untouched. The graves are still there at the bottom, while people on the surface are swimming and having fun. 200 years before the lake appeared, the Cherokee tribe had lived in this place. In the 1830s, they also got kicked out of their territory. Then, in the first half of the 20th century, there was a very big conflict between locals. The reasons for the conflicts are quite scary, so we won't dwell on them. But it's important to note that more than 1,000 people got hurt by this conflict and were forced to leave their homes. So, we have a place where tragic episodes have happened 3 times, and where a lot of people have been injured throughout history. Of course, there's no scientific evidence that those events had any effect on the lake. But if we talk about spiritual karmic plane, then see for yourself. Lake Lanier is considered one of the most dangerous lakes in history. 500 people have drowned or disappeared here since 1956, and almost 200 since 1994. About 11 million tourists visit the shores of the lake every year. About as many people visit the Louvre Museum in Paris. But don't think that accidents happen here because there are too many people there. A few dozen miles to the west, there's another popular lake, Altoona, and the same number of tourists come there every year. But there are almost 3 times fewer accidents there. For some reason, people drown at Lake Lanier, and motorboats often collide. There are no seasons with more or fewer accidents. So the cause of these tragedies may be hidden underwater. Many sunken boats, fishing nets, flooded villages, and graves lie at the bottom. Perhaps when someone dives here, they get tangled in nets, or stuck among debris or bump into rocks. Motorboats may not notice tourists passing by on air mattresses and crash into them. The water in the lake isn't very transparent, which makes it difficult to search for the missing. And then, there's also the legend that spirits inhabit this lake. Locals talk about phantoms who come out of the graves and try to pull the living under the water. Others tell stories about 27 ghosts of those who drowned in the lake over the years, but whose bodies haven't been found. But the scariest legend is probably the one about the Lady of the Lake. In 1958, 2 friends, Delamay Parker Young and Susie Roberts, got into their car. They drove to the gas station, refueled the car, didn't pay for the gas, and went to the lake. The evening started fun, but it turned into a terrible night. The girls drove off the bridge when they were crossing the lake and disappeared. For an entire year, no one knew what had happened to them, but people thought that the lake had taken them. One day, a local fisherman went to the lake to catch some fish and suddenly noticed a body in a blue dress floating near the bridge. It was poorly preserved, so the examination couldn't determine the identity of the person. But many locals were sure that the body belonged to Parker Young. Some people saw that day that she borrowed this dress from Roberts and put it on. But where was the other girl? And why was there no car? A few decades later, in 1990, authorities discovered an old Ford sedan at the bottom of the lake. They extracted the car and found the body of Susie Roberts inside. After this tragedy, locals started telling scary stories about how a transparent Parker Young in a blue dress grabs passers-by by their clothes and tries to drag them into the water. So, what do we have now? 3 terrible events have occurred at this lake over the last 200 years, affecting thousands of people. There's an old cemetery at the bottom of the lake, which the authorities decided not to move. 2 girls drowned there. At first glance, these events are not related to modern accidents. But honestly, we all feel and understand this connection inside. Places with such heavy energy and such a past may influence the present. Some skeptics will argue with this, but let's be honest, hardly anyone will buy a house when something terrible and tragic has happened. Today, Lake Lanier is more popular than ever. Millions of tourists, beautiful views, and picnics. Nothing suspicious, but you should still be careful. Just open the internet and read about the accidents happening there. Those missing people didn't expect their vacations to turn into a tragedy, so be very vigilant if you decide to come there. Now let's finish our video with something mysterious but more upbeat. How about the Vanishing Lake in Northern Ireland? You come there, swim, take cool pics, and decide to come back for a picnic with your friends. You come the next day with your homies, but hey, there's no lake. It's gone. Your friends are so angry. They come all their way there because of a silly prank. You feel like you're going crazy. Well, calm down. You're fine. There was a lake. In fact, it's still there. It just has a curious geological quirk. 3 streams fill this lake, but none of them can flow out. The lake fills up quickly, and then, when it reaches a certain point, it just flushes away, like the water in a toilet bowl. There are gaps at the bottom of the lake that are clogged with peat and debris. They act like bath plugs. But when there's too much water, these plugs fly out and the lake goes underground. So relax and come here another day when it's filling again. The road that leads to the lake is slightly raised off the ground so that people can walk along it. Previously, this road went underwater and reappeared. And don't be surprised if one night you see an old horse-drawn carriage on this road. It does look scary and creepy. Legend says that more than 100 years ago, a carriage with horses was crossing this lake when the water level was high. The carriage sank, and locals have been telling scary tales about the phantom ever since. In recent years, street lights across the U.S. have started glowing a weird violet hue that nobody could explain. And before you think we've slipped into a parallel reality, there's a much simpler explanation. It's a technical problem, and a rather eerie one. It all started in 2021. Back then, at least 300 streetlights that had been installed in Milwaukee began glowing with a purple hue. People described it as giving off a sort of an eerie cyberpunk vibe. That was definitely not good, especially for authorities, who had to figure out a plan to fix them quickly. Replacing all those lights was going to take about 10 weeks. Plus, the crews weren't exactly thrilled about braving Milwaukee's freezing December weather to get the job done. But the problem wasn't just happening there. Month after month, people in places like Kansas, South Carolina, Illinois, and Florida said they were experiencing the same thing. Of course, this kind of news is a goldmine for folks who love a good unsolved case. Soon enough, online detectives jumped in, and theories started flooding the internet. Like, maybe the lights were supposed to repel mosquitoes, or they were releasing chemicals for some unknown reason. And my personal favorite? That Prince's ghost was taking control of those streetlights. You know, like Purple Rain? Anyway, none of that made any sense. Because the truth is that purple hue isn't intentional. It's actually the result of an interesting and somewhat aesthetic failure in some LED chips. You see, from the very beginning of streetlights in the US, the whole idea was to keep things safe and make lighting more efficient. That's how we went from simple oil lamps to gas lamps and through a bunch of other attempts until we finally ended up with electric lighting. Then, about 15 years ago, cities across America started switching their streetlights from sodium lamps to LEDs. And that changed the color of many nighttime roads from a yellowish-orange tone to a bright white. Now this change makes total sense. LEDs are one of the most energy-efficient lighting technologies out there. Let's take an old light bulb, for example. With this one, 90% of its energy turns into heat, not light. But if we look at an LED bulb, it's the opposite. Only about 10 to 20% of its energy becomes heat, and the rest goes into producing light. They also last way longer. Now, LED stands for light-emitting diode. These tiny diodes can shine in all kinds of colors, but one color they don't naturally produce is white. So, when you see white LEDs, like the ones in streetlights and probably inside your own home, they're actually pulling off a clever trick on your eyes. To make white light, you could mix tiny dots of red, green, and blue LEDs together until they blend into white, kind of like mixing paint colors on an artist's palette. That's one way to do it. But there's another, more popular and energy-saving method that's usually used in streetlights. Instead of using 3 colors, manufacturers often start with just blue LEDs. But they coat these blue LEDs with a special fluorescent substance called phosphor. When the bright blue light from the LED hits this layer of yellow silicone phosphor, some of the blue light gets absorbed and transformed into red and yellow light. These new colors mix together with the remaining blue light, and voila! The glow looks white to our eyes. Now, you might be asking, why go through all this trouble? Well, making LEDs shine red and green takes more energy than simply making them shine blue. So sticking with blue LEDs and using phosphor saves electricity. Plus, it's simpler and cheaper because it needs less complicated wiring and few different LED chips. It's a win-win for cities trying to keep costs down and lights on. Of course, this phosphor trick doesn't work for everything. TVs and color-changing light bulbs need to produce many colors precisely, so they still use separate red, green, and blue LEDs. But when it comes to simply lighting up a street in white light, the blue LED plus phosphor method is the favorite choice. Normally, this technique works really well for streetlights, and the materials manufacturers use to make phosphor are extremely stable. But since this weird purple phenomenon is all over the internet, there's no denying that this is happening. So, specialists had to start looking for a cause. It turns out the phosphor coating had probably worn off or hadn't been applied correctly in the first place. Over time, the phosphor layer in some LED devices can start to break down, and without that yellowish filter, they end up shining more blue, giving them a purple glow instead of white. And the reason the problem only showed up after 2021 is because a specific batch of new streetlights that got installed all over the country. Thankfully, it seems like lighting manufacturers have figured out the issue. As a result, you're unlikely to see this problem come back in the next few years. And there you have it. No conspiracies, no Prince's ghost. Too bad. Just a little bit of color-mixing wizardry gone wrong. And little by little, the signature purple glow started disappearing as lamps slowly failed or got replaced. Now that's too bad for fans of the purple lights. Yeah, there have been plenty of reports from people who thought they looked nice. They felt the purple glow gave off enough light to see without being so bright that it hurt their eyes. But in the end, the lights had to be replaced for safety reasons. After all, streetlights are supposed to help you see when it gets dark outside, and the purple lights just aren't very good at that. Some people even had their houses broken into and blamed the poor lighting for making their neighborhoods feel more vulnerable. And then there's driver safety too. The color of the light shining on a roadway can change the way drivers see their surroundings as they make their way through the night. So inside your eyeballs are tiny helpers called photoreceptors. They come in two types, cones and rods. Think of cones as your daytime buddies. They love bright light and are the reason you can see all the beautiful colors around you. But when the sun goes down and things get dim, cones start slacking off. That's when the rods step in to save the day, or rather the night. Rods are the night shift workers of your eyes. They're super sensitive and help you see in low light, even if everything looks more like shades of gray than full color. But here's the thing. Rods are extra good at picking up light from the blue part of the spectrum. In other words, bluish light stands out more to your rods than other colors do in the dark. Now, most rods hang out in the outer edges of your retina, the part of your eye responsible for peripheral vision. So, when you're driving at night under bluish streetlights and you suddenly catch a hint of motion out of the corner of your eye, that's your rods doing their job. Under bluish light, they're even quicker to spot things moving around in your periphery than they would be under yellowish white lights. That boost in your peripheral vision under bluish light comes with a bit of a trade-off. Sure, your rods are great for spotting movement out of the corner of your eye, but the moment you try to look straight at whatever is moving, bam, it can suddenly get harder to see and focus. So it's not super safe for drivers. Okay, but does the purple glow actually affect our eyesight or cause any long-term problems? Manufacturers say we can rest easy because this effect is harmless. I mean, there's no evidence that anyone's been hurt by it. But it's true that blue light scatters more easily than most other visible light and can make it harder for your eyes to focus, especially in low light conditions. So, yeah, I guess we can all be glad that this purple lighting is finally going back to white. See?
Utah is turning into a desert, and it's happening way faster than anyone thought. In just a few decades, the state's most famous lake could dry up completely. And when that happens, huge clouds of toxic dust could cover entire cities, forcing millions of people to leave their homes for good. So, what is really going on? Utah is a western state in the US, and locals like to joke that it's already pretty much one big desert. And honestly, they're not that wrong. Most of the state is scorching hot and dry. In fact, Utah won the title of the second driest state in the entire country. But that only feels like a win if you actually enjoy temperatures of 101 degrees Fahrenheit. But when I say desert, don't picture endless sand dunes like the Sahara. Utah's deserts are more about canyons, rocky landscapes, and very scarce vegetation. And if you look at the state from above, a huge body of water immediately stands out. That's the Great Salt Lake, the largest saltwater lake in the entire Western Hemisphere. But soon, it might not even be a lake at all. Yep, this whole region is turning into a desert, no exception. That's a big deal because the Great Salt Lake isn't just any lake, it's essential for them. And there are 3 big reasons why. First, there's the cultural side. Long before any major cities ever showed up, it was already a place of deep spiritual meaning for indigenous tribes in Utah. Then there's the wildlife. This region is a crucial stop along the migration routes of about 10 million birds, including eared grebes and American avocets. For them, it's a place to feed, nest, and rest before continuing their journey. And finally, there's the economy. The Great Salt Lake is worth big money, bringing in about $1.3 billion a year for Utah. But its reach goes far beyond the United States and supports industries all over the world. This place is packed with brine shrimp, also known as sea monkeys. These tiny crustaceans are very important since they feed fish farms in dozens of countries. Believe it or not, almost half of the world's brine shrimp supply comes from the Great Salt Lake. But it's not just about these little creatures. This region also gives us magnesium, sea salt, and other minerals that keep Utah's economy running. It's such an important spot that it provides jobs for about 9,000 people. Now that you know how essential the Great Salt Lake is, here's the hard truth. It's drying up, fast. And there are 2 big culprits: the weather and, well, us. You see, the lake's been feeding the effects of shifting weather patterns. For a while now, more of the region's precipitation has been falling as rain instead of snow. And that's bad news. Snow is better for the lake because it piles up in the mountains and melts slowly, feeding the lake over time. But now, with less snow and more rain, the lake isn't getting refilled like it used to. And then there's the human factor. Starting back in the early 1900s, authorities began building dams, canals, and pipelines around the lake. The idea was simple: divert the lake's water to farms, factories, and the fast-growing towns nearby. People along the Wasatch Front have been actively diverting water from the lake for over a century. But in the last few decades, things have really ramped up. Think about it. Back in 1982, the Salt Lake City area had around 700,000 people. Fast forward to 2025 and it's about 1.2 million. That's a lot more showers, crops, and industry all pulling water away from the lake. And that brings us to where things stand today. Parts of the Great Salt Lake are now only about 40% full by volume. Sure, the water levels rise and fall from year to year, but overall, they've been dropping for decades. Back in the 1980s, the Great Salt Lake stretched over more than 3,000 square miles. By 2021, it barely covered 950 square miles. At this rate, the lake could disappear completely within just a few years. Pretty terrifying, huh? And the danger isn't just about the cultural history that could disappear, the millions of birds that could be lost, or Utah's economy taking a massive hit. The air itself could become harmful, turning this whole region into a dangerous place to live. Turns out, the sediments at the bottom of the Great Salt Lake are packed with materials that show high reactivity. In simple terms, stuff that could be bad, even toxic for us. When the lake shrinks, the exposed lakebed dries out and turns to dust, and that dust doesn't just stay put. It gets picked up by the wind and blown straight into the air. The problem is that the lake is pretty close to big cities, and the dust that could come from it might carry metals like manganese, iron, copper, and lead, all of which can seriously irritate your lungs. When that happens, it can trigger inflammation and lead to respiratory issues. experts believe it might also be connected to heart problems, developmental defects, and other serious health risks. These findings were published in 2024. At the time, scientists admitted they couldn't yet confirm whether those toxic substances were reaching populated areas. They still needed better equipment to track the wind and all. Even so, people were already worried. Then, in May of 2025, the headlines hit. A dust storm carrying toxic elements had, in fact, swept across the Salt Lake Valley, impacting residents in some of Utah's most densely populated areas. People in Magna and Tooele County actually watched a massive plume of dust roll right over their cities. So yeah, even though we still need more studies to know just how bad things could get, or if the biggest cities will be hit, groups like the nonprofit Grow the Flow say the disaster is already underway. They report that dust storms from more than 1,000 square miles of exposed lakebed are already drifting into nearby communities, affecting the air people are breathing right now. This is just one reason why the situation is becoming such a big crisis, and why the authorities are so concerned. But it's not like there's nothing that can be done. People in Utah are already taking steps to turn things around, or at least keeping it from getting any worse. Over the past few years, Utah's authorities have made getting water back to the Great Salt Lake a top priority. They've done it by creating special policies for farmers and setting up new tools to track water flows, for example. They believe those efforts are starting to pay off. The lake hit a historic low in 2022, but the winters of 2023 and 2024 brought above-average snowfall. When that snow melted, the water ran into rivers and helped the lake rise a little. That's good news, but not great. I mean, the lake is still several feet below what's considered an ecologically healthy level. So, they had to come up with more ambitious plans. And recently, almost 23 billion gallons of water were sent from Utah Lake to the Great Salt Lake through the Jordan River. To put that into perspective, that's roughly 750 Olympic-sized swimming pools. It's enough water to supply about 3,000 homes for a year. The good news is that most of Utah's lake water comes from snowpack melt. And not long ago, it was nearly 96% full. So this plan is a real win-win. It helps keep the Great Salt Lake at a healthier level, and it also helps prevent flooding at Utah Lake. This is probably just the start. Over the next few months, the Great Salt Lake could get another boost from more controlled water releases across its basin. Of course, this problem is far from over, but every drop of water helps. If these efforts keep going, Utah might actually have a fighting chance to save this precious lake and keep the area from possibly turning into a desert. Divers have found something incredible in a Florida sinkhole, and it was… Stop, we need to leave a warning here. You're about to hear some pretty unusual scientific information. This knowledge will make you the smarty pants in your friend group. But there's also a risk that they'll look at you as a nerd. So perhaps it would be better for you to keep this knowledge a secret. In any case, it won't be superfluous. So, you know that scientists divide the history of our planet not only by time periods, but also by which animals lived at a certain time. For example, 2,000 years ago, Earth was inhabited by the blobfish, and scientists call this time the blobfish period. It's a joke, there's never been such a period, but you get the gist. The period between about 419.2 million and 358.9 million years ago is called the Devonian period, or the Age of Fish. Do you know why? Because the first fish began to appear on the planet. The Paleogene is the period of large mammals. The famous Jurassic period marks the appearance of giant dinosaurs, which we often see in the movies. Even now, we live in a certain period called the Quaternary period. It began about 2.6 million years ago and continues to this day. This is the time of humans and modern animals. So the next time somebody asks you what time it is, you can just answer, it's the Quaternary period. In short, the names of these periods depend more on what creatures inhabit the planet. The longest period is the Precambrian period, or Age of Early Life, the time when life on the planet started to form. Soft-bodied worms and jellyfish swam in the ocean, while microorganisms lived on land. This period occupies almost 90% of the Earth's total geological time. It started about 4.5 billion years ago and ended 540 million years ago. Oh, it's still a video about divers, don't forget. We'll get back to them soon. Considering all these periods, do you know which one is of the most poorly studied? A period about which scientists know almost nothing, especially about the animals that lived at that time. This is the Irvingtonian North American land mammal age. It lasted from about 1.6 million to 250,000 years ago. Scientists have very few fossils that belong to this time, but recently, everything has changed. In the USA, there's the Steinhatchee River, which stretches for several tens of miles in the area of Big Bend, Florida. And just 500,000 years ago, there was a sinkhole instead of the river. This is a hole in the ground that forms when water dissolves the upper rock. This rock is often limestone. Sinkholes appear in places with a lot of precipitation. Sometimes these pits can be invisible. They look like ordinary ground, but the soil in them is loose and can easily collapse. If you accidentally get into a sinkhole, people will hear your screams and help you. But in the distant past, about 500,000 years ago, when animals got there, they couldn't get out of the pit, so it became their grave. After many, many years, a river appeared here, and then several fossil collectors decided to check out this place and discovered a real paleontological treasure in it. They plunged into the river and reached the bottom. There, in the murky water, they saw horse teeth sticking out of the sediment. It'd be pretty scary to find for many of us, but for these guys, it was the jackpot. After the teeth, they found a hoof shaft and the skull of an unusual animal. At that moment, the collectors realized they had made a major discovery. Over the years, the sinkhole at this place had been filled with sedimentary rocks. Then, the river compacted all this mass, which made it possible to keep everything inside the sinkhole in good condition. Many animals got trapped in this pit 500,000 years ago, and only now have people managed to get them out. More precisely, what's left of them. Divers have found more than 500 fossils belonging to ancient animals, including unknown species. They got well-preserved bones of ancient horses, giant armadillos, sloths, and a new species of tapir. The Florida Museum examined the remains and determined that they belonged to the poorly studied Irvingtonian North American land mammal age. Most of all, scientists were struck by two finds in this collection. The first was the remains of a giant armadillo-like creature, and the second was the skull of an ancient tapir. In case you didn't know, this is a very cute pig-like mammal that has a short trunk like an elephant. Divers in Florida found the remains of a distant ancestor of this animal, which may be a new unknown species. Most of the fossils in this sinkhole belong to early Caballine horses, a subgroup that includes modern domestic horses. The remains of horses are so well preserved that scientists have seen signs of wear on their teeth. This will allow experts to understand the diet of these ancient creatures. We often hear news about people finding the remains of ancient animals or dinosaurs in caves, ravines, or at the bottom of lakes. But imagine if they found such remains in a museum. It all started in the early 2000s, north of the Florida border in southwest Georgia. There was a mine where workers mined clay. One day, they found the remains of some ancient animals and gave them to the Florida Museum of Natural History. There, these remains lay in storage, waiting in the wings. And then one day, some guy started sorting them out and noticed a mysterious vertebra of an unknown animal. This little grab caught the guy's attention, so he returned to it over and over again. He studied it, trying to figure out what species the bone belonged to. One day, he realized the bone belonged to an unknown extinct lizard species that looked like a tegu. You've probably seen these predatory creatures that look like monitor lizards. So, the age of the bone was about 15 to 17 million years old. Let's wrap up our video with something weird. You see this piece of amber-colored stone with stripes? Or is it not the stone? It looks like an ancient seashell. So right now, you're looking at the oldest fossil in history. It's a stromatolite, and its age is, you won't believe it. Make a guess. 100 million years? 500 million years? 1 billion? No. This fossil is about 3.4 billion years old. It represents one of the earliest forms of life on Earth. No, not the stone itself. Stromatolite is just a playground. The early form of life here is these thin strips. They're called cyanobacteria, tiny single-celled creatures. Okay, what about the remains of something bigger? Some ancient animals, for example? Meet the trilobites. They lived here during the Cambrian period, which began about 500 million years ago. This is the time when many invertebrates and fish began to appear. Their exoskeletons helped the trilobites stay remarkably well preserved, considering their age. They were arthropods that looked like something between a spider, a scorpion, and a mutant from another galaxy. These animals lived for a very long time, and people find their remains almost all over the world. They appeared at the very beginning of the Cambrian period, survived it, and became extinct at the end of the Permian period. During the Permian mass extinction, when about 90% of all living beings were wiped off the face of the Earth. These creatures swam in open water, burrowed into the seafloor, or crawled along it. They lived like predators and scavengers. The front of the animal was protected by a strong head shield. It had crescent-shaped eyes and a calcified plate on its lower body. This plate covered its esophagus and mouth. It had several pairs of legs growing from its body. The trilobite could also curl up into a ball, like a woodlouse. Mount St. Helens is exploding. A massive earthquake is ripping through the area, and a side of the volcano is giving way, crashing down in a deafening landslide. A towering wall of rock, ash, and debris is roaring down the valley, flattening everything in its path. Then comes the blast, a sideways explosion of superheated gas and volcanic debris. Trees are snapping like matchsticks. Homes are vanishing under an ash cloud so thick it blots out the sun. Ashfall rains down on towns hundreds of miles away. People are scrambling for masks and fleeing roads blocked by mud flows called lahars, toxic rivers of volcanic mud. The air fills with dust. Emergency sirens scream. Airports shut down. Hospitals fill with people struggling to breathe. The sky glows eerie orange as lightning storms ignite within the ash cloud overhead. This nightmarish scenario might play out very soon. Mount St. Helens, the famous volcano that blew its top in 1980, is acting a bit restless lately. According to the U.S. Geological Survey, about 350 earthquakes occurred from February to June 2024, and 12 more from September 2024 to January 2025. It was like a bunch of tiny tremors throwing a party underground. Most were so tiny you wouldn't even feel them. But on May 31st, 2024, there was one that hit magnitude 2.0. It's just strong enough that if you were nearby, you might have felt a little rumble. Don't freak out yet, though. Over 95% of those quakes were super small, with a magnitude less than 1.0. Scientists say this is the biggest burst of shaking since the volcano last erupted in 2008. But the volcano has already done this before. In the late 80s and 90s, it didn't blow up, so more earthquakes didn't mean an eruption is guaranteed. What's really going on might be something called a recharge, which is like the volcano's version of refueling. Magma, the hot melted rock, slowly climbs up from deep underground and fills a big underground magma chamber about 2.5 to 6 miles down. When magma fills this tank, it can cause a lot of stress underground, which makes the ground shake. Right now, there's no other sign that the volcano is about to blow. No weird ground bulges, no extra gas leaks, no heat spikes. The USGS says this level of shaking can go on for years without anything major happening. The alert level is still at normal. But it was very different back on May 18, 1980. Mount St. Helens unleashed one of the most explosive volcanic eruptions in history. And it all started with a huge earthquake, bigger than magnitude 5. But this wasn't just any earthquake. It triggered a massive landslide that ripped off the top of the volcano and tore away the rock and ice that had been holding everything down like a giant lid. Suddenly, the pressure that had been trapping superheated water underground vanished. That water instantly turned to steam, and boom! It burst sideways in a powerful hydrothermal blast. And that was only the beginning. With the top gone, the magma beneath the surface suddenly felt free. It started rising faster, forming bubbles and erupting with terrifying force. For 9 straight hours, Mount St. Helens was sending ash and gas miles into the sky. This giant blast didn't come out of nowhere. The warning signs started months before. On March 16, 1980, tiny earthquakes shook the volcano for the first time in years. By March 27, after hundreds of quakes, Mount St. Helens had its first little steam eruption in over a century. It threw ash and rock into the air and blasted a crater in the icy summit. The volcano kept getting angrier. That crater grew fast and cracks spread across the summit. At the same time, eruptions went from 1 every hour in March to 1 every day by April. Then things quieted down for a while. Few people realized that the danger was just beneath the surface. By May, over 10,000 earthquakes had rattled the mountain. The north side of the volcano swelled outward, growing about 450 feet. It was a bulge so huge that it looked like the mountain was about to explode. Scientists knew that magma was pushing up inside, creating a hidden cryptodome, a giant underground pocket of molten rock. And then it blew, shattering the mountain and changing the landscape. On May 18, 1980, exactly at 8:32 a.m., a magnitude 5.1 earthquake hit Mount St. Helens. Without any obvious warning signs, the entire north side of the volcano, the part that had been bulging out for weeks, suddenly broke loose and slid away in a massive landslide. This wasn't just any landslide, it was the largest debris avalanche ever recorded on Earth. Imagine a giant mass of rock, dirt, and trees rushing downhill. It was like dumping 1 million Olympic swimming pools full of stuff into the valley. When the cryptodome got ripped away, the pressure inside the volcano dropped incredibly fast, and this sudden pressure release triggered a huge sideways explosion that tore through the landslide debris. This lateral blast was insanely fast, over 300 miles per hour, and it ripped through everything in its path. Trees were uprooted, forests flattened, and a giant cloud of ash and hot rock shot straight up into the sky. In just 15 minutes, that eruption cloud soared more than 80,000 feet high, way higher than an altitude of 35,000 feet at which commercial airplanes fly. The blast destroyed an area nearly 19 miles wide from west to east and stretched over 12 miles to the north. In the zone closest to the volcano, almost no trees were left standing. At the blast's far edge, the remaining trees were scorched and burned. A huge area, about 230 square miles, was covered by a thick blanket of hot debris. That sudden release of pressure also affected the volcano's plumbing system, all the way to the underground magma chamber. With less pressure holding it back, the superhot magma suddenly expanded and rushed upward toward the surface. Starting just after noon, fast-moving pyroclastic flows, superhot clouds of gas, ash, and debris, raced out of the crater at speeds between 50 and 80 miles per hour. Those flows formed what we now know as the pumice plain. Scientists say the eruption hit its most powerful stage between 3 and 5 p.m. When the violent phase finally ended, the summit revealed a brand new giant crater shaped like an amphitheater. All day long, the winds carried over 540 million tons of volcanic ash east across the United States. The ash was so thick it caused total darkness in Spokane, Washington, about 250 miles away. Ash also fell as far as central Montana and could even be spotted hundreds of miles farther east, all the way to the Great Plains, which is over 900 miles from the volcano. The massive ash cloud spread across the entire US in just 3 days and then circled the entire planet in just 15 days. But there was one more problem. The hot gas and rocks were so wild and fast that they melted and ripped up a lot of the snow and ice sitting on top of Mount St. Helens. That sudden rush of melted ice and water mixed with loose dirt and rock, creating fast-moving, dangerous mud flows called lahars. Those lahars tore down the mountain into the river valleys, and the biggest, nastiest lahar hit the North Fork Toutle River. As this muddy, powerful flood barreled downstream, it picked up more dirt and debris, growing bigger and stronger. It smashed through bridges, crushed homes, and finally slammed into the Cowlitz River, reaching its peak size around midnight, about 50 miles away from the volcano. The whole natural disaster took the lives of more than 50 people. After the eruption, the mountain looked like a wasteland, and scientists wanted to see how life could start fresh in such a harsh place. So, their unusual plan was to release a few gophers to dig around the barren soil. Those busy burrowers churned up ash and volcanic debris, digging deep enough to bring buried bacteria and fungi back to the surface. Tiny microbes, especially mycorrhizal fungi, are crucial because they help plants get water and nutrients. It's like hooking roots up to a nutrient highway. Within 6 years, places where gophers worked got covered with over 40,000 plants. At the same time, nearby untouched areas stayed mostly lifeless. The fungi helped plants grow in the soil that was otherwise nutrient-poor and lifeless. Even old-growth forests buried under ash bounced back quickly, thanks to their own fungal networks. But where forests had been clear-cut before the eruption, no such comeback happened. No trees, no fungi, just burned soil even decades later.
According to the United Nations, India became the most populous country in the world in 2023. Can you guess where the United States of America stands in that rating? It's number 3, and America is the 4th largest country in terms of size. It takes up some 6% of Earth's landmass. Plenty of space for 335 million people who live there, right? No need to squeeze them into one region. Well, not quite. The population of the U.S. is distributed pretty unevenly. Let's draw a line right through the middle of the country. It'll run from North Dakota in the north to Texas in the south. Once you input census data and do some math, astounding figures appear. 80% of the U.S. population lives east of the imaginary line. The remaining 20% live to the west. That's just 1 in 5 Americans. We're talking about large metropolitan areas such as Los Angeles, San Diego, and San Francisco. You don't believe me? Just look at a satellite map of the U.S. at night. The right part is shining pretty bright, right? But why? Why is there such a huge imbalance in population? Simply put, history and geography. The East Coast is the place where the U.S. became independent in 1776. These are the original 13 colonies. Soon enough, settlers started spreading westward. One important milestone was the Louisiana Purchase. Today, this region is mostly what we call the Midwest. The area aligns nicely with the Mississippi watershed. Yup, this means plenty of fertile soil ideal for agriculture. But does this automatically mean a spike in population? The demographics of the U.S. reveal that a majority of its citizens live either on the east or the west coast. This leaves a large patch of land in the middle of the country virtually empty. People know it as America's underpopulated belt. The area stretches from the Canadian border in the north to Mexico in the south. The total surface area of this strip of land is 350,000 square miles. That's twice the size of California. One massive piece of land. In fact, this narrow strip accounts for 12% of the contiguous United States. That's the U.S. without Alaska and Hawaii. The belt runs north to south through 7 states, but its population makes up only 1% of the total number of people living in the United States. Now, this doesn't mean that the area is completely empty. It's still home to just over 3 million people. That's roughly the population of the island country of Jamaica. But there is room here for many more residents. Let's take the example of Nigeria. Its total land area is slightly bigger than the sparsely inhabited belt in America. But Nigeria's population is a huge 206 million people. This makes it the 7th most populated country on the planet. Impressive, right? But why isn't the American Midwest living up to its potential? Well, time for one last history lesson. I've already mentioned how the United States expanded from the East Coast to the West Coast. This doesn't mean that the West was lagging too far behind. Take, for example, the cities of San Francisco and Los Angeles. They were incorporated in 1850. That's just 13 years after Chicago. The following year, Portland, Oregon became incorporated. You get the picture. And then, in 1869, the United States completed building its first transcontinental railroad. In terms of transport, the country was unified. There is no historical reason strong enough to explain why so few people live in the center of the country. So now it's time for some interesting geography. If you look at the physical map of the United States, you'll notice that this belt lies in the Great Plains. As the name suggests, the area is flat, which should be ideal for large settlements. Well, not really. East of this region, there is a huge patch of the color brown. It's covered by mountains. But not just any mountains. These are the Rockies. The range is around 76 million years old. It has several peaks over 14,000 feet. And most of the Rockies are national parks, a vast nature reserve. But most importantly, the range plays a vital role in the region's climate. Ever heard of the rain shadow effect? Let me explain. Wet weather systems form over the Pacific Ocean. Then they travel east, where they meet the Rockies. Now the air has to go up over the mountains. This is where it cools down and condenses. The final result? A lot of rain and snow for the people living on or west of the range. And just a few drops east of it. When air from the Pacific finally reaches the Great Plains, it doesn't contain much moisture anymore. In fact, the weather system starts taking up moisture from the surrounding landscape. This creates an arid climate east of the Rocky Mountains. That's the exact location of the belt where so few Americans live. It's one of the driest parts of the country. So when settlers came in the 19th century, they were like, nah, I'll just continue west. Plus, there was the gold rush in California they were heading for. The climate in this part of the plains isn't great for agriculture, and huge fluctuations in air temperature don't help either. In a single day, temperatures can drop from 70 to 30 degrees Fahrenheit. These sudden changes in outside temperature are harmful to human health. It's like stepping inside an air-conditioned room on a sizzling summer day. Not a pleasant feeling. Southern California has a similarly dry climate, yet close to 40 million people live there. This makes California the most populous U.S. state. Their secret? A vast network of irrigation canals and aqueducts, plus a share of water from the Colorado River. Summers in the Great Plains get very hot, while winters are extremely cold. The reason behind these wild weather patterns are polar winds. They get a piggyback ride along the ridges of the Rockies and then rapidly descend into the plains. A winter day in Wyoming, for example, can start pleasantly warm, but later in the afternoon, the temperature can easily drop below zero. You just wouldn't know how to dress, and you probably wouldn't want to relocate here. That's what 99% of Americans think too. Humans like to feel comfortable, so we choose to live in temperate climate zones. Places that are either too cold or too hot don't have a large population. Just look at the driest inhabited continent. You've guessed it correctly, it's Australia. Nearly 70% of the country is either arid or semi-arid. That's a subtle way of saying that it's a desert. That's why Australians are huddled in coastal areas. 90% of them live in big cities, such as Sydney, Melbourne, and Perth. The only exception is the capital, Canberra. They build it inland close to a water source. But Australia's interior is sparsely populated. Just like in the States, there is only one major town in an area the size of 12 Lake Michigans. A huge shout-out to the residents of Alice Springs. They truly live in an oasis. And what about places with a temperate climate, like Europe? The population is evenly distributed here, right? Well, yes and no, depending on the country. In Germany, 77% of people live in urban areas. They have plenty of major cities to choose from. Berlin, Hamburg, Munich, and Cologne all have over 1 million residents. But let's look at neighboring France. How many cities with a population over 1 million can you name? Okay, Paris, definitely. It has over 12 million residents in the metropolitan area. But now comes the staggering fact. The next two cities on the list have a population of barely 2 million, respectively. Can you notice the huge imbalance? This is the case in most large European countries. In Greece, for example, 35% of the population lives in the capital, Athens. So, the largely underpopulated center of the United States is not a unique example. America is the land of opportunities, but chances of finding a better life are greater in large cities. The country's top 100 metropolitan areas account for at least 3/4 of the nation's GDP, and most of them are located on the east and the west coast. There are no cities with over 1 million residents in America's underpopulated belt.
Off the coast of Virginia, the ocean floor was recently rearranged on purpose. Massive ships vacuumed up millions of tons of sand, carved shapes that looked as if a giant ice cream scoop had scraped the seabed. It wasn't a geological disaster. It was the first phase of one of the boldest and largest engineering projects in U.S. history. To understand why engineers are literally reshaping the seafloor, you have to look at the map. This is Hampton Roads, Virginia. This region is shaped by water. Two major cities, Norfolk and Hampton, face each other across a busy harbor. For decades, the main way to travel between them was the Hampton Roads Bridge Tunnel System, or HRBT, built back in the 1950s. It's basically a bridge that ducks underwater only at the ship channel, so cargo and Navy ships can pass above it. That system is now overwhelmed. At peak demand, close to 100,000 vehicles try to pass through this single crossing in a day, pushing it far beyond what it was designed to handle. The road was designed for a different era, when cars were bigger but the traffic was lighter. Today, it can regularly turn into a parking lot in the middle of the sea. But this problem goes beyond missed dinners and being late for work. It is also a national security crisis. Norfolk is home to the largest naval base on the planet. This is where the United States parks its expensive aircraft carriers and nuclear submarines. The base depends on roads. If a crisis happens, the Navy needs to move fast, and if the road is clogged, they'll get stuck in traffic. That makes the stakes incredibly high. At first, the fix sounds obvious. Too many cars? Build a bigger bridge. But Hampton Roads isn't a quiet river. Those aircraft carriers and cargo ships need a wide, unobstructed path to the ocean. A bridge becomes a low ceiling. You can't raise the bridge without blocking traffic for years, and you can't lower it without trapping the fleet. So, engineers chose the only option left. go underneath and create a unique expansion. The official price tag for this job sits at $3.8 billion. The goal is to create 2 new underwater tubes right next to the old ones, but the logistics here make it difficult. There's not enough land to start digging. The machine needs a dry launch pad to start the dig and a receiving pit to catch it on the other side. That's why the engineers decided to manufacture the land themselves. They brought in dredging ships that operate like floating vacuum cleaners. These vessels lower a suction head to the seafloor to inhale the seabed before pumping that mud water mix through miles of floating pipes. The output is amazing. The pipes shoot the mix up in high arcs that look like a cool, messy rainbow before it builds up on the surface. This process moved enough earth to expand the artificial islands by 15 acres, creating solid ground where there used to be open water. However, this was not just a simple vacuum job. This harbor has been a naval hub for centuries. The seabed is a graveyard of lost history. Dredging crews had to watch out for unexploded stuff hiding in the mud. We're talking about discarded explosives from centuries ago. Sucking something like that into a high-pressure pipe is a quick way to ruin the schedule. Once that new land was solid enough to stand on, the construction team needed a mechanical beast capable of eating through it. That's why they brought in a huge worm-like machine called Mary. Mary is way more than just a supergiant drill. She is a factory on wheels that stretches longer than a football field and weighs over 9 million pounds, roughly the weight of stacking 9 fully loaded jumbo jets on top of each other. At the front of the machine sits a massive cutter head, 46 feet wide, covered in steel teeth that spin to chew through the soil while the rest of the machine builds the tunnel behind it. Building a machine this large costs $70 million, and she had to be shipped from Germany in pieces just to reach the job site. But the coolest part of this machine isn't the steel. It's the human element inside it. Those cutting teeth don't last forever. Grinding through wet sand and silt wears them down, and eventually, someone has to go in and change them. You can't just crack open a hatch down there. You're deep under the harbor with tons of water and mud pressing in from every direction. Instead, crews work inside sealed, pressurized sections of the machine. Many of the tools can be reached from inside the TBM itself, but it's still tight, loud, and unforgiving. Every move has to be planned. Systems have to stay carefully controlled. The work is slow, deliberate, and tightly monitored because mistakes here are expensive and dangerous. Digging with Mary was a dangerous balancing act. The ground under the harbor isn't solid rock. It's soft, wet silt that behaves like toothpaste. This created a constant nightmare for the pilots driving the machine. If Mary pushed forward too fast, she would over-excavate, meaning she would suck in too much dirt. This creates a void underground that travels up to the surface. On land, that makes a pothole. In the ocean, it creates a massive sinkhole that could swallow the water above and flood the tunnel. But if she moved too slowly, the sheer weight of the Atlantic Ocean would crush the tunnel face inward. To stop the ocean from winning, Mary used a pressurized slurry shield to push back against the mud, keeping the tunnel face stable while her cutters chewed forward. As she advanced, robotic arms installed concrete rings behind her, turning a hole in the mud into a rigid, waterproof tube in seconds. Steering her was another headache. Mary had no windshield. The pilots were driving blind through the dark. They had to rely on lasers and computers to navigate a strict curve deep underground. They had to hit a tiny target miles away. If they drifted off course by even a few inches, the tunnel wouldn't connect, and the project would be a failure. Mary launched in 2023, and despite all the challenges, after 29 months, she made her final breakthrough in September 2025. While it feels like the finish line, it's really the end of just one phase. Boring the tunnel creates the hollow space, but crews still have to build the tunnel's nervous system. They are currently installing the roadway, power, and lighting. But the most critical piece of tech is invisible to most drivers. It's the ventilation. The biggest danger in an underwater tunnel isn't a leak, it's fire. If a car catches fire deep underground, the smoke has nowhere to go. To solve this, engineers are installing massive jet fans that look like aircraft engines strapped to the ceiling. In an emergency, these fans spin up to hurricane speeds to suck the smoke out and push fresh air in, keeping the escape routes clear. It takes all this complex tech to make an underwater tube feel like a normal drive rather than a survival mission. But the transformation isn't just happening underwater. Above the surface, crews are rebuilding miles of highway to connect the new tubes to the rest of the world. When the sand settles and the ribbon is finally cut, the landscape of Virginia will look deceptively similar. The water will still be there, the ships will still sail, but underneath the surface, the dynamic of the region will have fundamentally shifted. For the commuter, it means getting out of the traffic jam. For the Pentagon, it means the assurance that the Atlantic Fleet is never boxed in. But for the engineers, this project is a testament to something bigger. It's proof that not only we can build structures over obstacles, but we can also successfully transform the Earth to fit our needs. Engineers moved islands, vacuumed the seafloor, and bored through miles of unstable slime to create a path where nature never intended one to be. It's a fight against geology and a massive investment in national security. But in Hampton Roads, where the ocean meets the asphalt, it proves that the map is only permanent until it's time for another redraw. The country's authorities are hiding something from you. They don't want ordinary people to ever find out the truth. You can see a lot of fake photos and false locations on the internet, but almost none of them are true. So what secret are they keeping? You definitely don't expect to hear this. They're hiding a tree. But it's not just a tree. Money grows on its branches. Can you believe it? Of course not, it's a joke. But the truth is, America does protect the oldest tree in the world, and its name is Methuselah. You can Google it and you will find a lot of fake pictures and some old gnarled aspens. Real photos of Methuselah are quite rare, and its location remains a mystery to this day. It's known to grow somewhere along the Methuselah Trail in the Inyo National Forest in California. It's a bristlecone pine tree, and its age is more than 4,600 years. Imagine how cool it would be to touch the trunk of that tree and feel all those thousands of years of history. Only it's not cool. This is the reason why the country is hiding its location. If thousands of tourists touched the tree and picked up small pieces of its branches, it wouldn't last even a month. Many trees in this area are pretty weak right now and suffering from drought and all kinds of bad insects. So Methuselah is also in danger. Don't touch or approach it, even if you find out the location. The tree was discovered by dendrochronologist Edmund Shulman. A dendrochronologist is a scientist who studies the rings of ancient trees. But more on that later. So Shulman discovered the tree in the middle of the previous century, and over the past 50 years, it has become shrouded in rumors and legends. But how did Shulman know it was the oldest? In 1957, he took a core sample and studied the tree's annual rings. You see, every year, a layer forms inside a tree, resembling a ring. But scientists don't cut the trunk, don't worry. They extract a piece as thick as a pencil, and that's enough. The more layers, the older the tree is. So, Shulman counted Methuselah's rings and found out that it's been growing for more than 4,600 years. This means it's even older than ancient giant redwoods, which were considered the oldest trees on the planet. In 1958, Shulman told the story about the existence of Methuselah and posted its photo in National Geographic. From that moment on, the tree became popular. Many people wanted to pluck a cone or twig from it, so the authorities forbade publishing information about the location of the tree. Later, other scientists examined Methuselah's rings and suggested it could be younger, though some rings were too faint or damaged to count. In any case, it remains the most ancient tree on Earth, officially confirmed that is. But it wasn't always like this. Back in 1964, a geographer, Donald R. Curry, stumbled upon a tree called Prometheus, which was about 5,000 years old. And you know what he did? He just cut it down. There are many theories about why he did it. The tool for getting core samples was broken, or this guy didn't know how to use it, but the result was sad. The tree didn't survive. Hopefully nothing like this will happen to Methuselah and it will live a long life. But why are scientists so worried about it? Yeah, it can tell a lot about the history of our planet. But is there another reason? There's a theory that this tree could live forever if no one cut it down, and droughts or parasites didn't destroy it. So basically, Methuselah is like nature's fountain of youth. Imagine if we could use that trick on people. Okay, now we know what the US hides, but do you know what Australia keeps secret? Not just a tree, but an island. Even if you were allowed to visit the island, it wouldn't be easy for you to get there. The island is located between Australia and Antarctica, somewhere in the middle of the ocean. But it's unlikely that you would get such permission. The fact is that Heard Island is completely untouched by humans, and Australia wants to keep it that way. You'll find little reliable information about this island on the internet. All we know is that the island has 2 active volcanoes, Australia's tallest mountain, and several glaciers. But you know what the coolest thing is? It's home to animals you won't find anywhere else. The island's closed ecosystem preserves creatures that might have never seen people. The next island is quite famous and is located in Brazil. The authorities don't keep it a secret, but they protect it from tourists. Even if you had permission to visit this place, you probably wouldn't want to. This is Snake Island, and its name speaks for itself. This piece of land contains the largest concentration of venomous snakes in the world. Those are golden lancehead pit vipers. One bite of this snake is critically dangerous for a person. The snakes are all over the place there and have almost no competition from other animals. Only specialists capable of handling these reptiles can visit the island. Lots of secret places stay off limits because humans can mess them up without meaning to. It's not that we're bad, it's just that even being there can change tiny invisible parts of nature. And here's a great example of the kind of destruction we can trigger. You've all seen photos of ancient cave paintings with horses and bulls. One of the most famous of such caves is the Lascaux Cave, which is located in France. On the walls inside the cave, people found more than 600 drawings and about 1,500 engravings. The 20,000-year-old drawings depicted different animals. Scientists opened the cave to the public, and this led to a disaster. Too many people came to see the cave, and it messed up the cave's ecosystem. Then a fungus showed up and started spreading over the walls, ruining the old drawings. It was a tragedy for the scientific world. The cave was quickly closed to visitors. Now, only a small group of archaeologists can enter it. No one knows when or if the cave will open again. Those glimpses of human history from the first European settlements might be lost to the public forever. Our next secret location is in Svalbard, Norwegian archipelago. This is the Svalbard Global Seed Vault, a massive storage vault that can keep 4.5 million seeds of different types. The authorities say that the seeds are stored there to preserve the population in case of a local disaster. But a lot of people think they're tucked away for the apocalypse, ready to help us replant Earth if everything goes wrong. But why, of all countries, did people decide to store seeds here? Because of Svalbard's cold, dry climate. The weather conditions here are ideal for seed preservation. The vault is well guarded, it's classified, and no one can get inside except for authorized persons. All our secret places are connected with nature. An island, a forest, a cave. But how about finishing the video in the city? It's in plain sight, but it hides a secret room that is impossible to enter. In Atlanta, Georgia, inside a museum with top-notch security, the secret Coca-Cola recipe sits locked away in a massive safe. What? Yes, this is probably one of the most guarded secrets in the world. Money, diamonds, ancient artifacts. None of them get the kind of protection a single sheet of paper with the Coke recipe does. This secret has been kept there for more than 125 years. The unique storage design and security system make burglary almost impossible. You can visit a specialized museum and see the door to the vault, but nothing else. Sure, it sounds a little crazy to guard a single piece of paper, but then again, this drink has made the company billions. Coca-Cola has been one of the world's favorite drinks for over a century, and it's still raking in massive profits, so it's not surprising that its recipe is kept so secret. In Hawaii, the Big Island is quite literally expanding. Every few years, glowing rivers of lava spill from Kilauea or Mauna Loa and pour into the ocean, instantly turning seawater into steam and molten rock into a brand new coastline. Since the 1980s, eruptions have added hundreds of acres of new land. Far to the north, Alaska's capital has a very unique position. Juneau may look like any other city on a map, but there's one catch. You can't drive there. Huge mountains and massive glaciers block every route, leaving the town completely cut off from the rest of the continent. Seriously, the only way in or out is by boat or plane. Up in Alaska's far north, the city of Utqiagvik spends about 66 days in polar night from mid-November to mid-January with no sunrise. Then it flips to weeks of 24/7 daylight in summer. The Outer Banks in North Carolina are known for slowly moving west, getting pushed inland by waves and storms that scoop up sand from the ocean side and drop it on the sound side. It's known as the place where hurricanes can easily create new inlets. In California's Eureka Dunes, sand can sing. When dry sand grains move down a slope, they bump against each other and create a deep humming or booming noise that can last for several seconds. Scientists refer to this phenomenon as booming sand, but early explorers believed the desert was growling. Some places can't sit still, and others refuse to stop growing. The Rocky Mountains, for example, are still growing. Unlike the older Appalachian Range, which stopped millions of years ago, the Rockies are geologically young and active. It's a slow process that can't be properly measured, but we do know that they are rising. Did you know that rivers are not always content with their direction? In the 1800s, the Chicago River flowed straight into Lake Michigan, all the way into the city's drinking supply. After years of sewage and sickness, engineers thought of something original. They made the river run backward. They dug canals, blasted through rock, and rerouted the current toward the Mississippi instead. To this day, the river still flows the wrong way. Kentucky is famous for being split between two time zones. The western half runs on Central Time, while the east keeps Eastern Time, meaning you can gain or lose an hour just by driving through the middle of the state. The Nevada desert is filled with ghost towns. There are over 600 of them. Most were born overnight during the mining booms, only to die just as fast when the gold ran out. Wooden saloons, empty banks, and rusting rail lines still sit under the sun like movie sets left behind. But what about a ghost town that has a fire burning underneath? In Pennsylvania, there's a place called Centralia that's been on fire since 1962. A coal seam beneath the town caught fire and never went out. It forced nearly everyone to move. The ground still smokes even today. Another fact, my favorite one, is about the whole island full of monkeys. Near the coast of South Carolina, Morgan Island is home to around 4,000 rhesus monkeys with no humans in sight. The monkeys were brought there for research decades ago, and the population exploded. Visitors aren't allowed ashore, partly to protect the colony and partly, well, because it belongs to monkeys now. In Montana's Glacier National Park, there's a mountain where one raindrop can choose 3 paths. Fall on one slope and it flows into the Pacific Ocean. Another sends it to the Atlantic. A third sends it north toward the Arctic. The spot is called Triple Divide Peak, and it's one of the few places on Earth where 3 oceans share a single starting line. And if you think 3-way water splits are rare, there's also the Continental Divide that doesn't actually divide anything. In Wyoming's Great Divide Basin, rainwater gets trapped in the middle and has nowhere to go. It doesn't reach the ocean at all, it just evaporates or sinks into the ground. A lonely no-exit zone in the middle of the continent. Mount Washington is famous because it once held the record for the fastest directly measured surface wind at 231 miles per hour in 1934. That's faster than a race car and strong enough to knock you flat in seconds. Have you ever heard about Lake Superior? It's so vast that it holds about 10% of all the world's surface freshwater. The sheer size of it changes the weather. It is creating its own fog and storms. It's so extremely cold that it affects the air above and produces its own snow. What about bioluminescence? In Florida's Indian River Lagoon, microorganisms called bioluminescent plankton light up the water at night, turning it into a soft electric blue when stirred. It's a rare and beautiful sight to behold. In the middle of Utah's Red Desert, there's a natural bridge so large it looks engineered by giants. It's called Landscape Arch, a ribbon of stone stretching nearly 300 feet from end to end. That's almost as long as a football field, yet only a few feet thick at its narrowest point. A section of it collapsed in the 1990s, and today it's so fragile that hikers can only admire it from a distance. However, Utah hides another enigmatic structure called the Upheaval Dome. Scientists aren't sure it's a meteor impact or the result of ancient salt pushing upward from below. Either way, it's a massive circular crater that looks like the desert tried to grow a mountain in the wrong direction. In Arizona, we have the Barringer crater. It's one of the best preserved meteor craters on Earth, about 3/4 of a mile wide and nearly 600 feet deep. Scientists believe it was carved out 50,000 years ago when a space rock the size of a small building slammed into the desert at around 29,000 miles per hour. In Michigan, between the two peninsulas, there's something unexpected: a floating post office. The Westcott Company has delivered mail on the river since the late 1800s. The J.W. Westcott II has done it since 1949. It's even got its own zip code, 48222. The ship sails up to passing freighters and delivers mail by rope and buckets. It's the only floating zip code in the country, and proof that even the Postal Service can be creative and cool. On the East Coast, Maryland happens to be the only U.S. state without natural lakes. The ones you see, like Deep Creek or Lake Habib, are human-made. Even Arizona has a couple of natural lakes. They just dry up during drought years. Southwest of there, Florida likes sinking holes. Below the sunny beaches and retirement communities is a landscape made of limestone, which dissolves in water. This creates thousands of sinkholes ranging from little pits in backyards to huge underwater caves. Central Florida even got the nickname Sinkhole Alley. Off the coast is one of the biggest examples, the Green Banana Hole, which goes 155 feet under the Gulf of Mexico. In Arkansas, there's this cool park that you have to visit. You can actually dig for treasure there. It's called Crater of Diamonds State Park. It's the only spot in the US where anyone can hunt for real diamonds and keep whatever they find. The park is sitting on an old volcanic crater that brought diamonds to the surface millions of years ago. Oklahoma, however, is infamous for its tornadoes. It averages around 50+ tornadoes a year and ranks among the highest for their strength. Each spring, the sky there turns from calm blue to chaos in minutes. Another quirky place is in Wyoming. It's called Buford. It's known for having a population of just one person. It's right off Interstate 80, and for years, this one resident was also the mayor, store clerk, and postmaster all rolled into one. After about 2 decades, he moved on and the town got auctioned, complete with its gas station and the sign that proudly read, Population 1. Sounds haunted, huh? Well, that's it for today. I gave you 25 US facts to help you shine during your next trivia quiz. And you can hit like. See ya!
Now, this tiny town on a U.S. map used to exist only on paper, literally. Agloe was never built, never had a mayor, and yet, for a short while, it was officially on the map. Back in the 1930s, 2 map makers from American's General Drafting Company were hired to make a map of New York State. But they wanted to protect their work from copycats. So they created a ghost town and named it after themselves, Otto G. Lindbergh and Ernest Alpers. Take their initials, mix them up a bit, and you get Aglow. Or is it Aglow? Well, no one's quite sure, since it never existed anyways. You see, creating fake towns used to be a thing, because copying maps was also a thing. In the past, map making was serious business, and protecting your work wasn't easy. So cartographers got clever. They started adding tiny traps, fake streets, made-up lakes, even whole towns to spot copycats. These sneaky details were called trap streets or paper towns. If someone copied your map, they'd copy your invention too. It was a quiet way of saying, "Busted," and then taking them straight to court. Then the funniest thing happened. A few years later, another company published a map with Aglow on it. When confronted, they said, "It's not fake. There's a general store called the Aglow General Store right there." Turns out, someone had seen the town's name on a map and decided to open a shop under it. Today, the store is gone, and Aglow is back to being just a lonely road intersection in the Catskills. Now sometimes fake lands appear on USA maps not on purpose, but because of simple cartography mistakes. Take Isle Filippo, for example. This mysterious island with a fancy name was once proudly shown on maps of Lake Superior, even though it never existed. Back in the 18th century, French travelers were busy exploring the Great Lakes when they saw, or thought they saw, 4 islands out there. Let's just say their methods weren't always precise. But a French cartographer named Jacques-Nicolas Belin didn't know that. He trusted their travel notes and drew Isle Philippe on a map he made in 1744. The problem is that other map makers trusted Belin's work and copied the island onto their maps too. Before long, Island Filippo was as real as any place could be, on paper at least. It stayed on official maps, confusing travelers all the way into the 1820s. That's when explorers finally checked and realized, wait, there's nothing here but open water. Today, historians think the whole thing was a mix-up. The explorers probably confused it with Isle Royale, a real island that's part of Michigan. They were described as 2 islands about the same size, but there was only one all along. Next stop, Nothing. You heard that right, Nothing is the real name of a tiny ghost town in Arizona. If you ever drive down Route 93 between Wickiup and Wickenburg, keep an eye on the towers along the way. On one of them, there used to be a wooden sign painted in red letters that simply said Nothing. Hopefully it's still there. This spot marks what's left of a once hopeful settlement in the middle of the blazing desert. Back in 1977, a man named Richard Buddy Kenworthy decided to found his own town. He built nothing out of almost nothing. The place had a gas station and a tiny convenience store, but that was it. Then he added a big yellow sign that proudly declared, "The Town of Nothing, Arizona. Population 4." And yep, that was its peak, only 4 inhabitants. I know your family dinner table might have seen bigger crowds. But anyway, in May of 2005, Kenworthy packed up and left, and Nothing was officially abandoned. 3 years later, its famous gas station began to crumble. But some fans, I guess we can call them that, decided to bring Nothing back to life. There was even a small pizza place running there for a while, but it didn't last long. By 2011, Nothing was, well, nothing again. And today, it's one of the most famous abandoned towns in the USA. Now, speaking of abandoned towns, some were lost to time, others to something far more dangerous, like Centralia, Pennsylvania. From a distance, everything looks fine, but take a closer look, and you'll notice something strange. Roads cracked open, smoke rising from the ground, and no people in sight. That's because Centralia isn't just abandoned. It's been on fire for more than 60 years. It all started back in 1962. Although there were many theories about how the fire began, the results are well known. The flames spread into the labyrinth of coal mining tunnels running beneath the town, causing devastation as they went. Fissures opened in the ground, sending plumes of smoke and toxic gases into the air, and the fire never stopped. That's right. At first, no one thought much of it, especially because everything was happening underground, out of sight. But soon, smoke began seeping up through the soil. Then, in 1981, a huge sinkhole suddenly opened under the feet of a 12-year-old boy. Thankfully, he grabbed onto a tree root and survived. But that was all the proof locals needed that the fire wasn't going away. Experts warned that the underground blaze could keep burning for more than 250 years. And that's why most of Centralia's 1,000 residents decided it was time to pack up and leave. Today, fewer than 10 people still live there, refusing to move. The rest is nearly a ghost town, with empty streets and crumbling foundations. They don't even have a zip code anymore. Beneath it all, the coal is still burning quietly, making Centralia one of the eeriest forgotten towns in America. And now you might be wondering, how many more of these towns are out there in the U.S.? Well, a lot. Just in Texas alone, there are an estimated 511 ghost towns that are now completely deserted. Then there's Nevada, believed to be home to over 600 phantom towns, many of them left behind after the gold and silver rushes of the 1800s and 1900s. People moved there to work in the mines, and when the mines shut down, they left. But abandoned towns and mapping errors aren't just a U.S. thing. Even in the age of satellites and Google Earth, fake cities still manage to sneak onto maps all over the world. One of the most famous modern examples is a place called Argleton. Back in 2008, a guy named Mike Nolan was checking out Google Maps, looking around the area where he grew up, in West Lancashire, England. Then he spotted a city called Argleton, but something felt off. He remembered that spot being just a farmer's field near the village hall. Maybe a footpath crossed it, but that was about it. There was definitely no real city out there. And he was right. It was a total mistake. Nobody knows exactly how it got there, but it did. Don't bother looking for it, though. Argleton was officially removed from Google Maps by May 2010. And even if you look for its old coordinates today, you'd only see an empty, muddy field. Alright, so Argleton might have been fake, but it sure had a lot of fans. When people first discovered it online, they went a little wild. And then came all the jokes. People were actually selling souvenirs that said, "I visited Argleton and all I got was this t-shirt." Some local restaurants even offered Argleton pie, and the ingredients were, well, nothing. Believe it or not, even today you can still find merch online celebrating the world's most famous Google Phantom Town. Well, that's the end of our tour of the strangest ghost towns on the maps of the USA, and even beyond. So, tell me, have you ever been to an abandoned city before? Have you ever discovered hidden places on the map that shouldn't even exist? Well, share your story in the comments below. Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs, and if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored.
You can't even imagine how much benefit trees can bring. In the first half of the last century, America built a forest in the prairie states with the only scope to help countless people survive the Dust Bowl. That's what people called the devastating period of the 1930s, when the country faced extreme drought that destroyed farmers' fields. You've probably never heard of it, but America's forgotten green wall, made up of forests, saved an entire country from devastating problems. It all began in the 1930s. Severe droughts destroyed vast amounts of crops. Farmers were terrified. Powerful winds swept sand and dust across fertile fields, polluting and damaging the soil. The hurricanes also accelerated erosion and evaporated moisture, leaving the ground dry and barren. Cornfields and other grains produced almost nothing. A serious famine was approaching. That's why on July 21, 1934, President Franklin D. Roosevelt instructed a U.S. Forest Service to begin the Great Plains Tree Planting Project. Sounds great and promising, but how did America stop the Dust Bowl exactly? The idea was to plant as many trees as possible in long, wide, straight rows. These rows of trees were meant to act as a shield, protecting fields from strong winds, preventing erosion, and reducing drought. The tree belts also provided shade, cooling the soil and nearby water sources. They protected crops from wild animal pests and supplied people with an extremely valuable material, wood. In short, it was a massive climate restoration project. The Forest Service established headquarters in Lincoln, Nebraska, as well as in several towns and counties across Oklahoma. The official launch of the forest building effort took place on March 18, 1935, in the city of Mangum on the H.E. Curtis Farm, when the first shelter belt was planted. You might think that planting trees is simple, but you'd be wrong. It's not just a matter of tossing seeds into the ground, covering them with soil, and adding a little water. Let's take the pecan as an example. It's a fairly large tree with a wide, dense crown. If you choose to plant seeds directly into the soil, you'll need to spend a great deal of time and effort fighting weeds and pests. A seed requires more care and attention than a sapling because it's far more vulnerable. You don't just water the tree, you need to develop a proper irrigation plan. You don't skip meals during the day, so a seed also needs to receive water regularly. But don't overdo it. Too much water can destroy the tree. Many factors must be considered, such as soil temperature and fertility, so don't be surprised if nothing works out at first. A more reliable method is planting a sapling. You bring a young tree into a field, dig a hole of the appropriate size, moisten the root system, trim the roots and branches slightly, place it in the hole, and cover it with soil. As you fill the pit, the soil must be compacted. At the end, water the ground to firm it up. Cut off half of the tree's top to balance the root system. And by now, your head is probably spinning from all this information, but this is only the beginning of the work. As the tree grows, you need to paint the trunk white or wrap it with special protective covers to shield it from the sun and other damage. Don't forget about weeds and grass. They don't harm the tree directly, but they compete for the same moisture and nutrients the pecan tree needs. Then some insects and pests eat the tree and spread diseases. You have to choose special treatments to eliminate all these threats. So yes, planting a tree is not that simple, and we're talking about just one pecan tree. Meanwhile, America built a forest filled with mulberry trees, Osage orange, cottonwood, green ash, hackberry, red cedar, walnut, and many other types. Every day, farmers cared for all these trees. They watered them, fertilized the soil, removed weeds, fought pests, all under extreme heat. Of course, planting such a forest required more than just farmers' efforts, so the federal government actively supported them. If a farmer wanted to establish a shelter belt, they submitted an application. Special commissions evaluated the land designated for planting and tested the soil. If the land was fertile, the authorities approved the request. From that moment on, farmers began planting. Special government crews helped farmers build fences and fight rodents and weeds. Overall, it was a collective effort that produced impressive results in the form of well-structured forest rows. Each tree in a row was spaced about 10 feet apart. The width of the shelter belt ranged from 100 to 165 feet. Considering that the selected tree species had dense foliage, each belt formed a thick barrier that acted as a filter, cleaning the air of sand and stopping the wind. To improve the effectiveness of this filter, farmers planted tall trees in the central rows, shorter trees along the sides, and shrubs at the edges. The American Reforestation Project became so massive that by 1942, 220 million trees had been planted across 18,000 miles, stretching from North Dakota to Texas. Of course, not everything went perfectly. Some shelter belts were severely damaged and later removed by farmers. Many trees and shrubs suffered from intense droughts and locust infestations, and in some areas, farmers prepared the soil incorrectly. In 1936, tree survival rates were around 73%. In 1937, maintenance was fully transferred to farmers, and the rate soon dropped to about 61%. But why did damage increase once the government handed over the project? Farmers did their jobs well. Perhaps the problem was scale. It's extremely difficult to take care of such a vast forest, even with experienced people. It could happen that while farmers in Kansas were fighting locusts, powerful winds in Oklahoma were uprooting trees. But was the man-made forest in America worth it? Yes, the forest helped to a certain extent, but overall, it didn't save fields from the Dust Bowl as effectively as people hoped. But those trees became homes for countless birds and animals. Some internet users claim that in the 1950s, people saw a lot of pheasants in this area. Even today, according to forums, these birds still live in the old forest belts. Nowadays, locals see many trees in the prairie states and probably assume they appeared naturally. Few people know that all of this is the result of the hard work of many farmers, and that the real reason why America built a forest was to save the country. It's important to remember that. Today, the country is not threatened by drought or massive crop destruction as far as we know. Famine is not expected either. But why is it still important to preserve these shelter belts? Yes, they are vital for nature and support many animal species, but beyond that, they have very practical benefits for people. They protect the topsoil from strong winds. In winter, they keep roads from being buried under snow. Think about how blizzards can completely cover highways with thick, white drifts. Rows of trees significantly reduce snow accumulation. Farmers also plant tree belts between their farms and nearby roads. This creates a natural shield that protects animals and plants from dust, exhaust fumes, and traffic noise. So you can create such a shelter belt too. No, seriously. Many people dream of having their own garden or a single small tree. But what about an entire forest? Imagine how rewarding it would be to walk through it many years after planting. The farmers who created this massive shelter belt were surely happy about all the work they had done. You may be curious what's happening to the Great Plains shelter belt today. Does it still exist? By 2010, the condition of many shelter belts had declined. dense planting, aging trees, and the spread of other species competing for moisture and nutrients have all weakened these shelter belts. People have almost forgotten the American Reforestation Project. Fortunately, during those same years, the government allocated funding to maintain these forests in Kansas, North Dakota, South Dakota, and Nebraska. So there still may be a chance for them. One morning, millions of New Yorkers were going to work, just like so many times before, completely unaware they'd just missed an incredible bridge replacement project. A team of engineers and builders replaced the 3-mile crossing with a new structure built to last 100 years. But the real magical part is, it happened so quietly that nobody even noticed. The Tappan Zee was the longest span in New York State from the day it opened in 1955 until 2017. It wasn't close to being the longest bridge in the US, but if you look at it from above, you can understand why people made the comparison. The name Tappan Zee comes from two parts. Tappan, the name of the local Lenape group that lived in the area, and Zee, the Dutch word for sea. But the interesting part is why it was built there in the first place. It wasn't chosen for the scenery or the engineering conditions. It was selected because of a minor monetary technicality. Someone realized, if we move the bridge just a bit farther north, New York doesn't have to share a single toll dollar with New Jersey. And just like that, a line on a map decided where millions of commuters would cross the river for the next 60 years. When the bridge was finally built, it was the era of black and white movies, rebuilding, and material shortages. The designers worked with a tight budget and predicted the structure would last about 50 years. Back then, it made sense. Traffic was lighter, cars were smaller, and nobody in the 1950s was imagining 6-lane rush hours packed with SUVs, delivery trucks, and non-stop commuter traffic. But the world didn't freeze in the 50s. Suburbs expanded, highways grew, populations shifted outward. And day after day, year after year, the Tappan Zee quietly took on more than it was ever meant to handle. By its later decades, it was carrying over 140,000 vehicles a day. Replacing it wasn't like building a new playground while kids were still playing. Shutting the span down completely wasn't an option. Traffic would have overflowed onto roads that weren't ready for it. That's why engineers decided to build a new bridge right next to the old one. This is a standard, logical, and most common procedure for major crossings that cannot be closed. However, doing this for a bridge that was longer than many famous bridges in America, as long as the span of Central Park, wasn't exactly a walk in the park. So, how do you pull off the overnight bridge construction? Well, obviously not overnight. In fact, it took years, and it was insanely expensive. But to most drivers, it felt like waking up, looking out the window, and suddenly seeing a skyscraper that they somehow didn't realize was there. While drivers kept using the old bridge, crews built the new one right beside it using equipment normally only seen on massive coastal projects. One of the coolest machines used was the Left Coast Lifter, a floating crane nearly 330 feet tall. That's about the height of a 30-story building. It lifted massive pre-built steel sections, each weighing hundreds of tons, and placed them into position with slow, careful movements. Drivers could see the crane from the road, but because their route hadn't changed much yet, most people treated it like background construction. The new bridge grew piece by piece until the first half was strong enough to carry traffic. For drivers, it felt like the bridge was gently shifting and rearranging itself under their wheels, like a giant concrete puzzle, morphing into its new shape one lane at a time. It opened in small steps, planned so drivers wouldn't feel anything unusual under their wheels. Once all cars moved onto the new span, the old Tappan Zee was taken apart slowly and safely. Most of it was removed piece by piece using cranes and barges. One section had to be taken down with controlled explosives because it wasn't stable enough for manual removal. But even that was handled early in the morning with everything blocked off and secured. This entire U.S. highway bridge engineering project, the construction, the lane shifts, and the bridge's demolition and rebuild, was pulled off, and yet traffic never had to be shut down for too long. But what can we say about the new one? The old Tappan Zee Bridge was replaced by the Governor Mario M. Cuomo Bridge, named after a former New York governor. The name might not roll off the tongue, which is why locals still call it Tappan Zee, but the bridge itself is an astounding upgrade. It's a true modern structure, built to fix every weakness the original struggled with. For starters, it's much broader. The old Tappan Zee never had an emergency lane, which meant even a simple breakdown could freeze traffic for miles. The new bridge finally has space on the sides for cars to pull over safely for emergency vehicles to get through without weaving between lanes. The lanes themselves have been expanded as well to handle the demanding rush hour. It also has backup support systems built into its structure, so if one part fails, the whole bridge stays safe. Another new feature that everyone likes is a shared path for bikes and pedestrians. Now people can walk or cycle across the Hudson River, something impossible on the old span. Even the lighting was modernized. Instead of old orange bulbs, the new bridge uses bright, energy-saving LEDs that can change color for holidays and events. The new system is far more practical and easier to maintain. While the original Tappan Zee was built cheaply and quickly, this new one was designed to last at least a century. It has stronger materials, better corrosion protection, and a structure designed for today's traffic loads. But it came with a cost. And it's one question that people like asking when they hear about the upgrade. How much did this actually cost? And where did all the money go? And the answer is bigger than what most people expect. The entire project cost around $4 billion, making it one of the most expensive infrastructure replacement projects in the state's history. To many drivers, that sounds unbelievable, especially since they never felt a major interruption. But the price tag makes sense once you break it down. A large chunk of the budget went straight into the part nobody sees unless they're looking from afar: the foundations. The Hudson River near that spot is wide, deep, and uneven, and full of mud that refuses to cooperate. Engineers had to drill enormous steel piles deep into the riverbed, using machines parked on floating platforms. But then there's the bill for materials used. A modern cable-stayed bridge doesn't use bargain bin steel. It uses high-grade, corrosion-resistant, storm-ready metal and concrete, built to survive decades of trucks, wind, salt, and winter. And these weren't parts you can just pick up at a hardware store. Giant sections were custom-made in factories and shipped in by barge. However, this method was what made the whole overnight bridge construction process possible. The new bridge arrived in pieces and was literally pieced together. Labor and logistics made up a huge part of the cost. Thousands of workers rotated through scorching heat, freezing cold, fog, and rain. Coordinating barges, boats, traffic, safety crews, and big cranes beside a live highway is nothing like building on an empty lot. Every phase had to line up with the next, because one mistake could have shut down the whole crossing. That kind of workforce and planning is a big part of why the price tag was so high. But given that the bridge is breathtakingly long and will last at least a century, it looks like a significant investment. Replacing the old Tappan Zee wasn't about breaking records or building the longest bridge in the US. It was about proving that a massive bridge replacement project can proceed smoothly, safely, and almost invisibly. In the modern world, rush hours can feel like a never-ending nightmare, and thousands of outdated remnants will need to be replaced eventually. But if it can be coordinated without actually making someone late for a date or work, then it's truly worth admiring and appreciating. It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity: furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region, but that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, Cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries. Like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers, who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way, way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking, and the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land, so they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings, and they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling, and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the canal zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges.
Some mistakes have the power to change the course of history. One such story has to do with an old, boring key that could have saved the Titanic from its infamous demise. The key belonged to the crow's nest locker that housed binoculars, which could have helped the lookouts spot the iceberg sooner. There's more. The key wasn't even on board the ship when it set sail. The second officer took it with him when he was taken off the ship at the last minute. As the story goes, the officer forgot to hand the key over to his replacement in his hurry to disembark. So, when the lookouts were in desperate need of binoculars, they were out of luck. One of the lookouts, named Fred Fleet, even testified that if they had had binoculars, they would have spotted the iceberg in time to avoid it. And when asked how much sooner, Fleet replied, "Enough to get out of the way." In 2015, some auctioneers got their hands on Blair's key and presented it as one of the most important artifacts from the Titanic. They truly believed it could have saved the ship. Blair kept the key as a souvenir and passed it down to his daughter, Nancy. At one point, it was up for auction with a price tag of over $80,000. Blair himself was quite the hero, it seems. A year after the Titanic disaster, he was awarded a gallantry medal for saving a crewman who had fallen overboard while he had been on board the liner Majestic. He may have forgotten a key, but he sure didn't forget to be a hero when it counted. This next story is both funny and tragic. It's about NASA's lost $125 million Mars Climate Orbiter. The spacecraft engineers failed to convert from English to metric measurements before the craft was launched, and as a result, they lost it. The navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters, while Lockheed Martin Astronautics in Denver used the English system of inches, feet, and pounds. JPL engineers mistook acceleration readings measured in English units of pound-seconds for a metric measure of force called Newton-seconds. What's worse is that none of JPL's quality control procedures caught the error in the 9 months it took the spacecraft to make its 461 million-mile flight to Mars. That's a long time to be lost in translation, don't you think? The miscalculations were enough to throw the spacecraft so far off track that it flew too deeply into the Martian atmosphere and was destroyed when it entered its initial orbit around Mars. It's embarrassing to lose a spacecraft to such a simple math error. And it's hard to think of another example of such a large loss due to English versus metric confusion. Ever heard about the mathematical mistake that led to the discovery of the New World? Spoiler alert, it involves a guy named Christopher Columbus and a really big globe. Back in 1492, Columbus set sail from Spain with a mission to find a new trade route to Asia. He was convinced that he was less than 3,000 miles away from Japan, and just a bit more sailing would get him to the Indies with all their tasty spices. The only problem was that Columbus was a bit off in his calculations, like way off. He made a mistake in estimating the size of the globe, which led him to believe that Earth was far smaller than it actually is. Now I know what you're thinking. Wasn't Columbus afraid that he would fall off the edge of the world? Contrary to popular myth, Columbus and his crew knew the Earth was a globe, just like the ancient Greeks did 2 millennia earlier. They weren't worried about falling off the edge, but rather about the size of the ocean they planned on crossing. And to make matters worse, Columbus had no idea that an unknown landmass existed between Spain and Asia. After weeks at sea, Columbus finally reached the Caribbean. He believed that he had landed on the outskirts of Asia, and so named the islands the West Indies. He went on to explore the Caribbean and the northern coast of South America. But here's where things get really interesting. Even though Columbus insisted until his last day that he had reached Asia, another Italian explorer named Amerigo Vespucci mapped the eastern shore of South America down to Brazil and proved conclusively that Columbus had actually discovered a whole new world. A German mapmaker saw Amerigo's maps and labeled the new landmass America after him. And since his maps were super popular at the time, the name stuck. One man named Alexander Fleming stumbled upon one of the most significant medical discoveries of all time by accident. At one point in his career, Fleming observed the demise of many people from uncontrollable infections. Antiseptics were used to fight this, but they often did more harm than good. In 1922, while he had a cold himself, Fleming transferred some of his, nasal discharge to a petri dish and left it on his cluttered desk. When he finally examined it weeks later, he found that an enzyme had some antimicrobial properties. It wasn't until 1928, when Fleming left an uncovered petri dish next to an open window, that he stumbled upon the discovery that would change the world. The dish became contaminated with fungus spores. And when he examined them under the microscope, Fleming discovered that the bacteria near the fungus were dying. He managed to isolate the fungus and found that it was effective against numerous things that caused diseases. And thus, penicillin was discovered. As Fleming himself put it, "I did not discover penicillin. Nature did that. I only discovered it by accident." Talk about a lucky break. In the early 1520s, the east coast of the United States of America was a big mystery waiting to be solved. The Spanish found Florida, and the English and Portuguese found Newfoundland, but the area in between was like a blank spot on the map. France decided to take action and sent an expedition to explore the area. They chose a guy called Giovanni da Verrazzano to lead the trip. For this expedition, he got 4 ships. Unfortunately, 2 of them were shipwrecked, and a third one went home after doing some other business on the Spanish coast. Only the flagship, La Dauphine, crossed the Atlantic with Verrazzano and his 50-man crew. Verrazzano set sail from Madeira and landed at Cape Fear. From there, he sailed south, but got a little scared of running into the Spanish, so he returned somewhere north of Charleston. He anchored not far from his original landing spot, but unlike other explorers, he preferred to anchor well out at sea. He did send a boat to the shore, and he met the natives. They were described as wearing just some animal skins covering their bodies and garlands of bird feathers. As Verrazzano sailed along the coast, he reached the outer banks of North Carolina. He thought that the waters he discovered were those of the Pacific. In reality, what he'd stumbled upon was the Pamlico Sound. He thought that North America was just a long, extremely narrow strip of land. This mistake led mapmakers to show North America as almost completely divided in two. Moving on, Verrazzano reached a beautiful place that he called Arcadia, probably Kitty Hawk, North Carolina. Sailing further north, he missed the entrances to Chesapeake and Delaware Bays because he kept quite far from the coast until New Jersey. Then, the moment we've all been waiting for, Verrazzano discovered New York Harbor, and he anchored in the Narrows. Later, it was named after him, and now it is spanned by the Verrazzano Narrows Bridge. Once Verrazzano's sea appeared on the map, it became widely accepted and impacted loads of future explorers. For example, Henry Hudson went looking for a passage to the Pacific in the middle latitudes of the continent. But, as it turns out, the Englishman never did find the Pacific Ocean anywhere near Virginia. And the cartographic myth eventually faded away. It's funny to think about how a mistaken belief could have such an impact on history.